architecture has always been a key focus in archaeological research. It's because it dominates the context where the investigation takes place. However, there's a dearth of research concerning the vernacular architecture within the built environment of the Virgin Branch Puebloan people on the Shivits Plateau. This stems from the sediments of the area having obliterated most floor features, leaving behind the masonry retaining walls and scattered wall fall. As a result, the context provides limited data pertaining to their vernacular architecture. Nevertheless, my research is to understand the building methods of the Virgin Branch peoples, and with this limited data, I am replicating their pueblos. Supposed to gas. To compensate for this lack of structural evidence, I utilize architectural building information modeling programs, which I refer to as BIM, not BEN. In combination with data from Dr. Karen Hari's excavations and from ethnographies of ancestral Puebloan descendants, I will be explaining to you the sites that are used for data, the materials and methods for determining wall and roof construction, an explanation of what BIM is, how BIM is incorporated into the research, and how its results give us further insight into the Virgin Branch culture. So let me give you some background concerning the Shivits Plateau. The Shivits Plateau is located within the Grand Canyon Parashant National Monument in northwestern Arizona. This area exists within a cold semi-arid climate where the summers are hot, the winters are cold, and it receives an average of 13 to 15 inches of precipitation annually. The sites used for this research come from Dr. Hari's excavations and include the Lava Ridge Ruin, Dotza, and Bart sites. These sites consist of multi-room contiguous pueblos containing habitation and storage rooms. Each floor in a room has a finished floor elevation that is on average 35 centimeters below the adjacent ground surface. Non-coarse masonry walls with stones of varying sizes retain the ground surface. However, this is all that remains of the structures, with the above-ground walls and roofs having collapsed 1,000 years ago. Furthermore, the local sediments of the area have obliterated any post holes and have left us with very little to go off of. So how did the Virgin Branch people construct their pueblos? The revealed context from these excavations indicates that the ancestral Puebloan utilized rubble masonry for construction. This is using undressed stone set in mortar to form the walls. There are different ways to make mortar, and part of the research is to determine how they made their mortar. This includes determining the water quantity, since surface water is scarce on the Shivits Plateau, and mortar requires a lot of water. To determine the makeup of the mortar, we are currently having geologists testing samples of wall mud. We selected the smectite clay-rich soil from around the sites as the control sample because it is the base for the mortar. Since smectite clay cracks from shrinking and expanding, it needs a stabilizer. Therefore, the goal is to determine what the ancestral Puebloan mixed with the clay. A stabilizer reduces the cracking from the shrinkage and expansive qualities of clay. The most basic type of mortar uses sand as a stabilizer for clay-rich soils. After testing different mortar concoctions on the Shivits Plateau, we are strongly supporting a simple sand-clay mixture with a sand-to-clay to water ratio of 2 to 1 to 1.2. Nevertheless, the mortar composition is only a part of the ancestral Puebloan building method. Researching the building method involves asking additional questions. How much labor was required? What materials did they use? How much material did they use? What are the factors that determine size, location, layout, and orientation? And are the rooms habitable all year round? The best way to answer these questions is to construct a Pueblo replication on the Shivits Plateau. However, this takes a lot of planning, and even after you're set and ready to build, you have to get permission from governing bodies, which we did not. That's okay. But what if you could replicate a Pueblo without physically building one and get all the information you need to answer these important questions? That is, be able to determine material quantities, solar and thermal analyses, minimal structural design, and labor hours. With building information modeling programs, I can construct a Pueblo digitally and obtain the data necessary to answer those important questions. This is accomplished by inputting the data from Dr. Hari's Shivits Plateau excavations and from the ethnography of ancestral Puebloan descendants, such as the Hopi, Zuni, Toa, etc., into the building information modeling programs. Building information modeling, which is BIM, is CAD software currently used in the construction industry that digitally constructs buildings as 3D models. However, it is more than just 3D modeling. It combines multiple processes such as architectural design and structural, mechanical, plumbing, civil, and electrical engineering into a single model. The programs used for my research are Autodesk's AutoCAD 2014, Revit 2014, and Ecotech 2011. By utilizing BIM to construct the Pueblo digitally, this project has created material takeoffs, analyses, and construction documents. The material takeoffs indicate material volumes for different building elements, including how much soil is cut. For analyses, I have a solar analysis and a thermal analysis. In addition, BIM is able to produce construction documents with keynotes citing Dr. Hari's excavations and the ethnography. The material takeoffs provide a breakdown of the different materials used in construction and their respective volumes. These quantities can be further broken down to specific building elements, such as certain walls or roofs. In addition to figuring out masonry, wall mud, and mortar quantities, I can determine how much clay, sand, and water were needed to make the wall mud and mortar. For example, a simple room that is 12 meters square, 2 meters tall, with 25 centimeter thick walls requires 3 cubic meters of masonry and 5.5 cubic meters of mortar and wall mud. The mortar and wall mud can be further broken down to their components. These results are 1.86 cubic meters of clay, 3.72 cubic meters of sand, and requires 584 gallons of water. Thank you. Since BIM can provide structural information, I am collaborating with structural engineers to create a structural analysis of the Pueblo. These results are providing a framework of what the Pueblo would at least need to be structurally stable. The data output consists of size and quantity of vigas and joists, and if any posts are needed. Once the lumber is determined, in combination with the material quantities of the walls and roof, I am able to estimate how many person-hours are required to construct a Pueblo. The labor estimates are derived from Gilbert Glennie's reconstruction efforts as described in his 1983 master's thesis. These algorithms that determine the material sizes, quantities, and labor hours are inputted into the BIM program so that when you digitally construct the Pueblo, the program will output these estimates. For example, the simple room would require 35 joists with a 9.5 centimeter diameter and 5 vigas with an 18.7 centimeter diameter. To collect that much lumber would take 30 person-hours. To construct the room overall would take about 100 person-hours to complete. Solar and thermal analyses were conducted on the Pueblo. These analyses are important because they conform as to how the sun affects the building method, both ritually and environmentally. By factoring in the orientation, material values, and the day-to-day weather, the results indicate that the rooms are habitable year-round with a small fire during the winter, and yet remain cool in the summer. This analysis incorporates body heat, solar thermals, wall insulation, and other heat sources. In addition, by calculating the heat sources, we can determine how much fuel is spent, such as wood quantities, to keep the Pueblo warm. For example, we can calculate the temperature of a room that is occupied by 5 people wearing loincloths at 2 p.m. on a typical July 3rd. Yes, we can. In addition, the solar analysis informs us as to how the sun interacts with the built environment and the local topography. That is, we can see if boulders that are erected at the entry to a plaza cast a shadow which may act as a calendar for the inhabitants. Also, if there's any relevance with the orientation and location of site elements with where the sun rises and sets. The great thing about BIM is that it is upgraded 3D modeling. By exporting the BIM model into 3D Studio Max, great visual renderings can be produced. In addition, we can 3D print the BIM model. This includes the structure on its topography and practically at any scale, including life size, and thereby enhancing the visual experience. Through inputting ethnography and excavation data into BIM, we have begun to construct the Virgin Branch Puebloan built environment digitally. The BIM data will hopefully answer questions concerning the impact of the Pueblo on its inhabitants' culture and create new questions. In the future, I hope to be using BIM to study other cultures from around the world, both past and present. Therefore, today's processes are helping us to design and build our future, are helping us understand our past, our present, and ultimately the human condition. Thank you.